And share my screen. All right, everybody can hear me? Can I get at least?
Yeah.
Okay, great.
Yes.
All right, so again, we're doing section 8.1. This is systems of linear equations in two variables. And so I'm just going to start steadfast with example 1 because all it is, it's substitution. So they are determining whether ordered pairs.
Dr. Braza, we can't see your screen.
Awesome. That's fabulous. Isn't that a great way to start?
It's inspirational.
Inspirational is the word. How about now? Can you see it now?
Yeah.
Good now.
Oh, awesome. Determining whether ordered pairs are solutions of a system. So this is basically substitution and a little bit of math. Very lengthy description of something that's so easy. So we consider the system. This is a system. It's basically a linear system where you have two values or two linear equations, just like that. What they're asking us to do is to check. So part A, they give us a coordinate pair of 4, -1. So this is x, this is y. And it has to work for both. Okay, so when I plug this in, so I should have 4 plus 2 times -1 is equal to 2. And the question is that true or false? Obviously this is true. This works, right? Because all I'm doing, if you follow the color code, here's x. Let's do y in green. I'll plug in y in here. And if this matches right here, if this number matches this number after we substitute and apply our basic math, then we have true. Yes, this works. In part B, however, they're giving us the coordinate pair -4, 3. So in this case, I have -4, 3. Again, an ordered pair. So this is x, this is y. So if I plug that into the equation, I'll have -4 minus 2 times +3. Right? Because I'm going to take the 2 and multiply it times +3. And according to the equation, this should equal 6. Well, I get -4. I end up with, since it's a -2, I'm substituting in a +3. I get minus 6, so I end up with a +6, and this equals 2. So we're substituting in 4. This actually originally is a plus, not a negative, is it? On the equation that they give us. This is x plus 2. So we do it on the first one. I actually use the second one to prove that it isn't. In this case, you get -6, not +6. But it has to work. So you notice here, we don't get the same number. We get -10. So obviously this is not the equivalent equation. Because -10, as I substituted it in, did not match that. If you plug these numbers into here, you're good. But we could do that real quick. Because it has to work for both. So I'll repeat the process for part A here as well. So part A, I was substituting in this case, what was I substituting in for those two? This one was 4, -1. So again, using our values, we would end up with, for the first one, I'm going back to this one, which is this equation. I'm going to have 4 plus, what am I doing? Oh, I'm doing this equation, not that one. That's what it is. So 4 minus 2 times y, which happens to be in this case negative 1 if I substitute it in. And notice that I end up with 6. So we're good. This is using this equation for the first one. All right, so I'm using the first equation, not the second equation. My mistake. On B, what I didn't do was the first equation, so let me skip that part over and go back. So I'm using this one for B now. So in this case, I should have negative 4 plus 2 times 3. And this is going to result in positive 2. So that works for the second equation. So in other words, you're going to take this equation and the blue equation, and you'll use the coordinate pair for both. Right? So you'll use that twice. And you'll repeat the same process. So it has to work for both. Both must work. If one fails, then the coordinate system is not. So it does not work. So negative 4 comma 3 is a fail, because if you notice, when we plugged it in to the second equation, it did not work. So this is a fail for that coordinate. The first coordinate that we used, which was the coordinate 4, negative 1, that was a double win. So for the second coordinate pair, we had a win and a fail, so therefore no good at all. Okay? Do you want to try one on your own? Or do you have
Yes.
it? Yes, you want to try one? Okay. So let's try the system where we have 2x minus 3y equal to negative 4. And we have the system 2x plus y equal to positive 4. So that's your system. They're asking you to check whether the coordinate pair for A, which is 1 comma 2, works. And then they also want you to check whether B is a solution, and that one is coordinate point 7 comma 6. So remember, it has to work for both respectively. So when you do this, you're going to do it twice, once for each equation. Go ahead and go. I'll give you 2 minutes, should be enough. Do you agree with me so far?
Yes. Yes.
Good. So, not a solution. All right. Good job. All right. Do you feel okay with that?
Yes.
Yes.
Yeah, move on. Okay. So let me do example 2 with you. And I will post a video for you so you have something to look back on in case you need help. So here we're solving a system by substitution. And so I'm looking at 5x minus 4y is equal to 9. We're looking at x minus 2y is equal to negative 3. Okay, the hint with substitution is usually this. You see how that x is by itself? What I'd want to do is add the 2y and bring it to this side. So that'll cancels. And you're now left with x is equal to negative 3 plus 2y or 2y minus 3. It doesn't matter. The idea is that if I'm substituting in x, I'm going to plug it into the original first equation. And so now I have 5 parentheses negative 3 plus 2y minus 4y is equal to 9. Now I can solve for y. First thing I'm going to do is distribute the 5 to get negative 15 plus 10y minus 4y is equal to 9. Second thing I'm going to do is combine like terms. So I have negative 15 plus 6y is equal to 9. I'm going to add 15 to both sides of the equation. So it'll cancel on this side, leaving me 6y is equal to 24. And therefore, y is equal to 4. Well, wonderful. If y is equal to 4, then x is equal to negative 3 plus 2 times 4. So basically 8 minus 3, which leaves me x is equal to 5. And that's the actual solution to this equation. So the solution would be a coordinate pair 5, 4. And it would work for both equations. And you can always go back and try and see if it does work. So let's do it for the sake of practice. So if I do 5 times 5 minus 4 times 4, don't I get 25 minus 16, which is equal to 9? So we check out that the 9 works, right? Or this works. We do the same thing here for the original. So we're going to say 5 minus 2 times 4 is equal to negative 3, if that is true. Well, 5 minus 8 is equal to negative 3. Right? And so based on the fact that we completed that from the original 2, it should work anyway, right? All right. Do you want to do a practice one of those?
I feel good about it.
Yeah? Nobody else wants a practice?
Can we do one more just in
Okay,
case?
absolutely. All right, so here's the try question. So I'm going to give you this system. You're going to solve by substitution. Here's 3x plus 2y is equal to 4. And here I'm giving you 2x plus y is equal to 1. Find the solution. Give you 2 minutes. All right, when you take a minute, look up, see if you have the same final response as I do. Again, this is solving by substitution. Are we good?
We're good.
Okay. Anybody having issues? No? Move on?
All good.
All clear. Awesome. All right. Huh?
I said, yeah, I got it too, so we can move on.
Super. All right, I'm going to move up. And again, remember, I am recording the video after all. Let's see if it takes. All right, so let me hit you with example 3. And this time we're solving using the addition method. Now, here's the thing. I know sometimes they tell you on tests to use this method, use that method, and unless we're checking for your work, any one of these methods would work at any given time, as long as you follow the rule that's implied. So, all right, so we're solving by the addition method. They're giving us a system where we have 3x plus 2y is equal to 48. And here we have 9x minus 8y equals negative 24. So this is looking good. What I would suggest is, you see how this is a 2 and an 8 and this is a plus minus? The x's do not necessarily have the opposite sign. That would lead me to simply multiply this entire top by 4. Do you understand why? You see the plus minus already there? So this line up here is going to become 12x plus 8y equal to, and then 48 times 4 192? Yeah, 192. All right, and so now we're really going to forget about this middle line because we already changed it. We didn't change its value, we just changed it. And now look how cool. This will cancel with this. You don't have to worry about that middle.
Wait, Dr. Barrazo.
Yeah.
So what did you have? Where do you get the 4 again?
Because 4 times 2 is 8. And since their signs are opposite, it'll cancel it right away.
Okay.
So that's what I'm looking at. And the only reason I chose to do the y cancellation is because these are plus and minuses of each other. So if they're the same, if this is an 8y, which it became an 8y, it'll be a positive. When you combine that with a negative 8y, they'll cancel both out.
So if the x was negative, then we would multiply the top by 3?
Yeah.
Okay.
Just make it easy for yourself. Now, that doesn't mean that we couldn't have done the top. I could have changed the letter or the coefficient value for that and done that as well. So I could have used, for example, a negative 3 times 3x, which would give me negative 9x, and canceled the 9's out and then continue to work out the rest. But it's already there for you. Why change it? So I'm left with 21x, which is this plus this, equal to 192 minus 24, which is 168. And your last step, divide by 21 on both sides. And you end up with x is 8. Now, we need to find y. So let's go back to any one of our originals. I'm going to use the first one, which was the 3x plus 2y equals 48. And so if I throw this x equals 8 in here, I get 3 times 8, which is 24, plus 2y equals 48. And I know you're brewing the question, well, why not use the 9x minus 8y minus equal to negative 24? You could have. I'm not stopping you. But just remember, this is getting substituted in here. All right, if I subtract the 24, I'm left with 2y is equal to 24. And therefore y is equal to 12. And that's your solution set. Your solution set is 8, 12. How easy was that?
Easy.
Easy peasy? Is there anyone who would like to do a second example of that? Or shall I move on?
Could we try one?
Try one more? Okay. You're going to get plenty of practice in your homework, but let's do some here. All right, so you're going to solve by the addition method. All right, and I'm going to give you for x plus 5y equals 3, 2x minus 3y equals 7. All right, I'll give you a couple of minutes. Go ahead, try that, and let's see how you do. How are we doing so far?
Really well.
Awesome.
Yeah, all good.
Yeah, can I make a
Oh,
suggestion for this one just in case? Because I know I mentioned that you should always take a look here, but these are different numbers, so you would have to multiply the bottom by 5 here and the top by 3 here, which is totally acceptable. But then I'm looking down here and I'm thinking, well, it's so much easier if I just did -2 down here all the way across, because I only have to distribute this on one line. So I'm left with -4x, so the x's go away this time, right? -2 times -6, well, that's positive 6y. So I'm going to be left with 11y over here equal to, and then -2 times 7, well, that's -14. -14 and 3, that leaves me with -11. So it's very easy to denote that y is equal to -1. Done. Instead of having to do the 3 here and the 5 here, multiply it, get 2 different lines, which is totally acceptable. It just takes a little bit longer. Then my other step obviously would be to substitute in the -1 in here. So if I did 4 times x plus 5 times -1 is equal to 3, I'm left with 4x minus 5 is equal to 3. If I add that 5, that's how I get the 2, right? Because this becomes 4x is equal to 8, and therefore x is equal to 2. So that makes sense, right? So your solution point to -1. If you did it the other way, you'd still get the same answer. Just a suggestion, it takes a little longer. All right, are we good? Everybody got this? Regardless of which way you went?
yes.
All right. Is there anybody crying in the background not talking to me? Or we are good? Okay. In example 4, this is the same type of question. So I'm just going to put it here. And I'm going to let you look at it for a minute. And I want you to tell me why they're giving you this example and what do you need to do. So let's just have a conversation. Forget about working it out. Why are they giving you this mess?
So we can move the variables to one side and then go from there.
Exactly. They just want you to do some sort of x plus or minus y equal to some number on all of those equations. So, what would you recommend for this one? How would we fix that? Because we want x, then y, and then some answer. So the 2x is already on the right side. What about the y?
So subtract 7y.
Subtract the 7y and leave this guy alone, right? What would you need to do to the bottom one?
Add 3x.
Add the 3x. Leave the 5, which is positive 5y, and leave the 17. All right. Now, fair warning, I'm not going to ask you to do this one, but you get some weird xy values. Do it for homework so we don't waste time on that. It's the same process as the first part. As a matter of fact, I'm going to ask you to do this one for homework and the try question for homework. The only thing that's a little different with these is just that you get weird answers. And you're going to doubt yourself as far as your answer. So I think it'll be good to let you go here from the umbilical cord and have you try these for homework. And then we'll talk about them tomorrow morning or tomorrow during our class. Okay, so these are what we call one solution. Okay, so we have exactly one solution. That's what you have been doing.
Wait, Dr. Barraza?
Yes.
Nicole says she's in the waiting room.
Okay. Let me
Yeah,
let her
because
in.
yeah.
So this is what we've done thus far. All right. Questions that have only one solution. What we're going to do next are the no solutions. So you remember where if you have a quadrant, right? So you have a quadrant XY and you're looking at one solution where you're looking at two lines that are in essence going to have a shared point. So we call them one solution equations. All right. The ones we're going to do next are called no solution. So for it to have no solution, we are talking about, if you recall back when you learned this, if you've never seen this before, you'd understand easily just by looking at the picture I'm going to give you. Parallel lines. These were the no solutions. The drawing is awful. I'm aware of that. So basically we're looking for two equidistant lines. I'm going to give it one more shot. Come on, come on, come on. Parallel, parallel. Oh, that's pretty decent. Parallel lines have no solution. So these are the ones we're going to do. Here's what you're going to look for. You're going to look for a false statement. That's what you're looking for. And what a false statement would do for you is, let's say I had 4x plus 6y is equal to 12. And let's say I gave you 6x plus 9y is equal to 12. You can use any method you like. So what I'm going to do is I'm going to build them up. I'm going to build these up right here, the x's. So I'm going to multiply this one by 3 all the way across. And I'm going to multiply this one by -2 all the way across. When I distribute, I'm going to write it over here. I'm going to get 12x plus 18y equal to 36. Here is -12x minus 18y is equal to -24. Now, if you notice, I'm going to cancel this. I'm going to cancel that. So I've got a big old 0 sitting here. And 0, according to this, is equal to 12. Interesting. Does that make sense to you? That 0 would equal 12?
No.
Yeah, so that's how you know it's no solution. Now, before I continue, this is still the same process you would use. Do you remember when they did the third type and they said to you the third type of system of equation would be overlapping lines? So if I have a line going this way and another line overlapping the same line, we refer to it as infinitely many solutions. You know the difference between these two would be in the answer? Very simple. Say I had an equation that read, and this is example 6, by the way, infinitely many solutions. So in this example, it would say y is equal to 3x minus 2. Now use whatever system you want to do. And the second line would say 15x minus 5y is equal to 10. Could we use substitution? I mean, after all, y is equal to this, right? So I have 15x minus 5 times 3x minus 2 is equal to 10. If I distribute this value, notice what I get. I get 15x minus 15x plus 10 equals 10. So guess what happens to these two guys? They go away. Is this true? Is 10 equal to 10?
Yes.
Yeah.
Yes.
You notice that they are the same on the right and the same on the left? That's how you know to answer that there's infinitely many solutions. And so for this one, you would say the values of x and y are in the set where y is equal to 3x minus 2. You could also say the set xy, and always in a set solution. The values where x and y are in the set where 15x minus 5y is equal to 10. They're the same. So there's absolutely no difference in the process how you solve for this. All right. So let me give you another try to do at home. So the try that I gave you for home was this one.
Can you go?
Was
Can you
this
go back?
one? Huh?
Can you go back to the sets, please, at the
Yeah.
bottom?
Where are we? Here?
Yeah, right there, right there.
Dr. Barrazo, for the previous try, is it okay if we round?
You got some ugly decimals, didn't you?
Yeah.
You should have gotten as a fraction. One of your values would have been
102 over
X,
51.
yeah, for X you get 34 over 31, and for Y you get like 85 over 31.
Oh, okay. Thank you.
Nasty little numbers. So yeah, let me give you a third one to try at home, which is basically a regurgitation of what we've just done. So let me give you, I'll write it in red. So try this one at home. This is X is equal to 4y minus 8, and then 5x minus 20y is equal to negative 40. So this one is a third question for you to take a peek-see and see how you do. There are only examples 7 and 8 remaining here, but they take a little bit of time and practice. So I'll finish those with you tomorrow, and then we'll start section 8.2 and finish that as well. So I'm going to stop the recording right here, but we'll keep talking together. Let me see if I can do that real quick.